Good morning, everyone. Let's continue with the rest part of chapter 1. So for this part, we'll talk about AI history and AI benefits and risks. So we just conclude as SAMs. So that means some important topics related to AI applications usage. That means how we use AI. Of course, in this chapter, we only just give a brief introduction. You can find it from the book. We only have one section. But as explained in the syllabus, we cover the AI ethics in the last chapter. So that will be an important topic for us to learn as well. Though we don't have maybe projects, but we may have homework. So but most important thing is that I believe this information, this topic is important. So we want to do good things, do good to the humankind. Okay, let's first start with the AI history. So the important thing for AI history is just want to give you a brief idea what is going on in the past of the AI development. What's the techniques have been proposed and already matured, and what's the going up, what's the going down. Maybe you have ever heard AI has gone with 2 winters. So this is also an interesting thing that I mentioned before as well. So somebody also mentioned about whether we have a 3rd winter coming. Okay, but most people don't agree with that conclusion. We have another winter coming, and I agree as well. That means with the majority of the researchers, that means the idea with the majority of the researchers. I believe with the development of AI will become more and more popular, more and more important, and there's more and more problems with AI usage. So that means we need to use rules, regulations, and governance to set rules for AI usage. We want to do good things. We want to use AI to benefit for people rather than just use AI to hurt our human beings. Right? Okay. So this one is Turing. Right? So you know this one. This is some pictures about it's about you can see it's like coding something. Okay, maybe this is usage in the World War II. They use this one to decipher some signals during the wars. Okay, let's look at the first one, the history. So in fact, the word AI, artificial intelligence, somebody think this word is not a good word. So artificial intelligence means you want to mimic or simulate human intelligence. That's why we call it artificial intelligence. So many people think maybe it's better to use machine intelligence. So that means not want to simulate human intelligence, just want to make machine to think, to see, and to work, to create. So this is called a human machine intelligence rather than simulate human intelligence, right? Because maybe they have different working mechanism. They don't want to follow the same process as our brain. Okay, but anyway, just due to the tradition in this meeting, we can say this is just the first time this word has been proposed, has been used. So we call the Davos meeting. In that meeting, that important meeting, the several big guys like Minsky and some Simon. So we mentioned here maybe. So they just came up with this idea called artificial intelligence. Okay, I think in the Davos College, that's famous college as well. Okay, So before that, because for this one, it seems like the breakthrough, the breakthrough of the new subject or new direction, which is different from previous subjects, not unlike a database, not unlike algorithm, also not unlike only just computer vision or natural language processing. So we give a new topic to it called artificial intelligence. But before this year, already have some development for something. So let's look at. So in 1940s, so that means it's almost just during the World War II. During that time, people want to simulate a human brain, so they just create neurons. So neural, when we talk about neural, we'll talk about later. So you can think about it's just like, okay, it's a cell, okay, it's a neural. So this neural can receive information and also can output information. And then in between we have some activation function. Activation function means just like, for example, you have input X and then you have output Y. So this is activation function, input, and this is output. This activation function, that means how to activation, okay, function. So that means you use ignite this cell to map from input to output. So it's just like a transform from the input to output. We call this one is just like how our human brain smallest unit works. Okay, like this one, we have neural. Okay, so that means next one. Then this is the first mode of neural. So we will talk about this one as well. X, you can find here, we may have multiple X So that means this each X will be which input Xi will be combined together based on weighting. So in fact, X is not only one value, it can be multiple. So we have this one. Okay, so this is I. So I can from 1 to n. You have n inputs, and then we weight it together. Okay, for example, like you want to do image processing or image object detection, you may extract multiple features, and each feature is Xi. So you combine by weighting, weighted together based on some weight. Of course, you need to learn the weight as well. So that's the idea. Okay, so that means, for example, if we combine these several features, can we just identify what is the image, just for classification, So this is the class, this is the input image. Okay, you get some features. If you do object detection, you want to detect the objects, give the object location. Okay, if you want to do object recognition, you want to give the class, or classification, you want to give the category. Okay, so this is the first event about this neural networks. So that means here, but only have one neural. So neural networks, we have a list of neurons, and then they will connected to each other based on, later we'll talk about based on this weights. We need to learn. Okay, so that means here is just only about the model for one neural, and after we have the learning mechanism, so that means how we train the neural to work. For example, from the input to the output, how can we decide the weights from Wi? Learn this weight Wi, and how to select the activation function, and then training. So you may have no idea about what is training. So training, you can think about, for example, now you are learning from my course. So I will teach you something, and then you can utilize this knowledge to work on something unknown. This is called a test. So training is just like you have a supervisor, and they will tell you this is what, this is what, this is what, and then you can utilize this information to do something unknown. Okay? I teach you this is apple. Okay, I give you an apple image. Okay, if you meet apple again, you know this is apple. I give you another example. For example, this is orange. Okay, you know this is orange. So this is called supervised learning. If I teach you all the categories, teach you all the examples for which can cover all the categories, that's called supervised learning. But if I only teach you some, for example, I teach you apple, orange, but I didn't teach you banana, so you need to learn something else. What is banana? Okay? At least you know this is not an apple, this is not an orange. Okay, because they have a very different appearance. If you like that, that's called a semi-supervised. Semi, that means some know, some unknown. That's called a semi. But if, for example, you don't have a teacher, you just learn by yourself, that's called unsupervised learning. Okay, so that means we divide the learning into three things: supervised, unsupervised, and semi. Okay, so just understand this one. So here is like, how can we train the neural to learn the weights? So here we said we have a Habin learning rule. Okay, Habin learning rule. So Habin is a person, right? Herb, and then just named after his name. Okay, so anyway, I think when we talk about neural networks, we cover this part, so you understand what is going on in the past. That is enough. And then we have the cybernetics. Cybernetics is just learn the control and the communication things. For example, our human brain, what is the control, okay? But this one is related to maybe communication control of our brain work, how our brain works. So that means at the time people already have interest in our brain, human brains. And then after that we have Turing test. We will talk about this one. Okay? When we talk about the just for example acting like a human. Okay? Acting like a human. We use the Turing test to use it. We use it as a guideline or rule to see whether it has intelligence. So Turing test, of course, is named after Turing. Turing award I mentioned. So just proposed this Turing test. And then after that we have perceptrons. So what is the relationship between here neural and the perceptron? So neural is only one cell, okay, one neural, and perceptrons means only one layer, but you have multiple neurons, okay, and then we get one result. That's called perceptrons, okay. And then how to train one layer network. So that's the topic in that decades. And after that, people proposed computer chess and checker programs. That means propose some program which can play chess with people and also checker. So chess and checker are two games. When we talk about games, we also cover this one, I think in the chapter 4. Okay. So next chapter we are about agent. Next we about search. Yeah, uniform and ununiform search. And then next one we talk about games. Maybe chapter 5. Maybe, yeah. We have two chapters for search. Informed and uninformed. And then after that, people also started to look at the machine translation. So they want to translate languages from one to the other. And also they have some breakthroughs. but the translation quality is still not good enough. Okay, but there's some breakthrough at the time. People already started this, but even till now, you can find that more than 70 years passed. Okay, so the translation has a lot of improvement, but it's still not perfect. That's you can find. You need a breakthrough in some research region is really takes time. Okay, taking time. And then also people want to use the machine to prove mathematical conjectures, so-called theorem provers. Okay, so talk about these persons. They also have some successful stories. They use the machine to prove mathematical theorem. Okay, and then in 1956, that's the famous meeting we mentioned before. Okay, in the beginning of this slide. So in the Davos meeting, the first time artificial intelligence was proposed, was used. Even till now, we still use artificial intelligence. So just like for example in the past, okay, we call computer. Sometimes in China we call is like a electronic brain. Okay. But in fact, later we don't just only use computer, or sometimes we said calculator, okay, electronic computer. But computer is only for computing, okay, things like. But later we use computer for a lot of things. When we do, for example, we use it to watch TV, for entertainment, play games. Okay, like this one, of course, you can think about it still like computing something, but usually is information processing, okay? Or sometimes we use it for communication. Okay, so that means initially we give one name to it, and then due to this tradition, people use it. But it does not mean it is only for that purpose. Okay, so artificial intelligence. So later people propose use machine intelligence, maybe better, more appropriate. So cannot just use one to represent all. Okay, so this is artificial intelligence is not really just want to simulate our human brain. In fact, later we always use the third definition, acting rationally. Okay, rationally not only humans, and acting, okay, not simulate human brains, not like just like a thinking humanly. So if artificial intelligence seems like too narrow, okay? But anyway, just keep in mind, you understand artificial intelligence is not only about humans' intelligence, and also is not only about thinking, simulated thinking. So we use the acting rationally, so it can simulate the behavior of a lot of things, other insects, other animals, okay? Not only just human. Rationally, acting rationally, not thinking, okay? So not just about the simulate the thinking mechanism. Maybe after several decades, people can do thinking rationally maybe as well. So if like that, because for example, if like that, artificial intelligence maybe become a good word, better word, okay? But under current situation, this seems not the best word to cover all the most popular algorithms currently. Okay, so let's look at. So the Davos meeting is 1956, and then after that, because we have artificial intelligence, people are very optimistic. So or optimistic, they are maybe irrationally optimistic. Okay, so for example, Herbert Simon, of course, is one of the big guys in that Davos winter meeting, and then he said these famous words. Okay, more precisely, within 10 years, a computer would be chess champion. and important new mathematical theorem would be proved by a computer. Okay, so for example, it's not my aim to surprise or shock you, but just to mention about this is 1957. Okay, there are now in the world machines that think, that learn, that create. Moreover, their ability to do their things is going to increase rapidly until it is feasible, until in a feasible future. The range of problems they can handle will be coextensive with the range to which humankind has been applied. So anyway, just like the machine can quickly do the similar things as a human, right? So within 10 years, we have a chess champion. That means people will be defeated by computer. Okay, within 10 years, that means 1967, right? Less than. And important, that means we can use this one to prove mathematical theorems as well. But in fact, the practice is after 40. This prediction came true now, but after 40 years, not 10 years. Okay, not 10 years. So this is too optimistic. So for example, like we mentioned, in 2016, the AlphaGo, the AlphaGo. So that's the Go game. Of course, before that one, I think the chess, we have the chess. So the Deep Blue, the Kasparov has been defeated by computer as well. So, but that's the 2007, 2007. Okay. So, but that means usually when something achieved a very important breakthrough, people will think it is very promising, and they may have some unrealistic expectations on AI, on these things. And then, but after time's been, for example, after people become comfortable, and then we know we need to take time. We need to be more cautious in making the predictions. So I think this is also similar like the last 10 years. For example, we mentioned before, deep learning becomes very hot, becomes raise attention from industry, academics, research, even common people, and also many TVs and news and related to artificial intelligence, deep learning. So it's very like 2016, 2017, and after 2017, 2018, and people become more comfortable, and then know, okay, it takes time for those startup company to get some output. We're really working. So I think this is good. So that means that people will do these things, but will do it in a realistic way, not like just unrealistic. We want to get a output, tomorrow. We want to get a rewards tomorrow after we invest. So that's in fact is a better way is better for AI, rather than we just spend a lot of money on waste the funds, and then people don't do anything else, only do this one thing. So no people will do the farming, manufacturing, teaching, and the learning. They just they want to go into the bubble. That's not good, Okay, so I think a current stage is better. It's good for AI. So in the after 2018, it's better in the for example after summer. So there's the vendors become more realistic, more cautious in investment and so on. Okay, that's good, So we learn the lessons from the past. Okay. Also, there's a lot of debates on these things because maybe even in the early of 2018, somebody already mentioned about the winter coming. Okay. So this, of course, will give people let them cool, right? Let them cool. And then, so this one you can find is still during that hot, the boom region, right? In 1958, New York Times published one news about a new lec1 device learns by doing. Okay, just talk about these things. That means, of course, this is really new things. Seems like a brain. They can learn by doing self, like reinforcement learning. Right? Of course, you can find the lec1. So that means you need in military related applications first. They have more of resources. Okay, let's look at. So this one is, in fact, later people found it's harder than originally thought. Okay, after almost 10 years, 1956 till 1966, and then Elixir, we already mentioned about that chatbot. But that one is not a real chatbot. It's like a simulation how chatbot will look like. Looks like. So in fact, for that one is based on the pattern recognition, pattern matching. So they already pre-coded the questions, the framework, the templates, and then based on the keywords for your questions, they will find the matched templates and then add some information from your question, and then that's it. Okay. So for example, you said something, you talk about a mother, this keyword, and then the chatbot will ask you, tell me more about your family. Mother, of course, there's family, okay? And continue. For example, like this one, the chatbot can match, okay? Can just like complete the blanks, okay? Can match and match a template and fill in the blanks. So for example, it can say, I want you to adopt a puppy, but it's too young to be okay. This is I think is human, right? And then for example, this is just show wrong word, right? So I want to adopt a puppy, but it's too young to be separated from its mother, and then it will match this one because it's just mother didn't understand the word. It's about, in fact, about the puppy's mother, not about your mother. Okay? So tell me more about your family. Okay, so this is wrong. Okay? Just show red means this is wrong. So you ask this question, then you will make a mistake. Okay, this one maybe if I mention about my mother and okay, tell me more about your family. It seems like reasonable communication between a human and another human. Okay? But if, for example, I can easily make it doing some mistakes, correct? So like this one, fool. You can easily fool the machine because this one is just like a simulation of the human communication. Okay, human maybe natural language understanding, natural language processing, like these things. But at least, okay, for that time, people just want to show what it will look like if we do it successfully. And after that, we do translation. We mentioned about people already started before 1956. People already started a human machine translation. But let's look at what is data translation. So this is called a Georgetown IBM experiment. Okay. So this one, in fact, they can only do very simple one. They can translate 60 Russian sentences into English. Okay, completely automatic translation of more than 60 Russian sentences into English. But they only have 6 for this 60 Russian sentences. They only have 6 grammar rules and then limited words, vocabulary, restricted to organic organic chemistry. It's about only chemistry topic. So this translation is not general, only chemistry and only 6 grammar rules and only 250 words. So we know chemistry, we have more background information. Focus on this one. We make it easily to translate to another language. And then promise that machine translation would be solved in 3 to 5 years. But you can look at this press. But in fact, till now has not been solved. Okay? So, and then next one is another example called about just like after, because you said you can solve it within 3 to 5 years, but after more than 10 years you still cannot solve, and then there's some other argument. Okay, automatic language processing advisory committee mentioned about the machine translation has failed. So people have unrealistic expectations. They want to get results quickly, but if you cannot meet their expectation, and then will make them disappointed quickly as well. So this is a very important lesson we have learned in front of the first winter. Okay, so there's some words. The spirit is willing, but the flesh is weak. Or you can say the vodka is strong, but the meat is rotten. Okay. So anyway, just like for example, we have a very high expectation, good promising algorithms, but not easy to get results in a short period. So that means still it takes time. Okay, we don't say this is not a good topic, but it just need to take time because it's more challenging than you think. Okay, machine translation. Later we talk about, we don't use some rules to do that translation later. We use big data. We use a lot of data. We process a lot of documents. So now you can find that Google translation is much better now, but it still has less quality than human translation. Otherwise, you can find United Nations, there's a lot of translators. So if we don't have an issue, we can use a human translation, use a machine translation. Okay, and also talk about during that time computer vision is become popular, and then human people want to understand the word, means make machines see. We say make a machine think, walk, and sing, talk as well, think. So for example, at that time people just use blocks word. So for this one, you can find that we can understand the relationship between the objects, but we use blocks to represent object. So that means must have some regular object we can do that. This is called a blocks word. So it's only some initial exploration in the computer vision. That means make a machine see, understand the word. Okay. For example, they may have some occlusions. Okay, we can do some estimation, even we have the occlusions. But this is only for simple ones. How about this one? Like this street thing. We have more irregular objects. We need to detect. Of course, now we have a lot of advancement in this one, computer vision we mentioned. Okay, but at that time, so this is only very naive work. Now human can already develop very good algorithms using deep learning. We mentioned in the visual information processing, people can do very successfully in detecting objects, even better than human. For example, you may not be easy to recognize the objects, the small objects, but the computer can do that. So that's the recent breakthrough. So object detection, object recognition, object classification, and also maybe scene related things. Scene like this one, street, restaurant, classroom. They also have much better performance than before. I think based on this one, it's already like human intelligence. That's why you can find that the autonomous driving cars become more and more popular, just because they can recognize the object, not only the size but also distance and also the whole, the 360 degrees, just all around. Okay, even better than human, right? Because human, when you drive, you still have some region cannot perceive. Okay, let's look at continue. So late 1960s, and then we have this one, machine translation deemed a failure, okay, we mentioned, and then neural nets deprecated as well. So that means neural nets seems doesn't work, because at that time even people already have some algorithms to train a network. So not only perceptions, just a network of neurons, but their performance is still not satisfactory. They cannot only make breakthroughs. So using some traditional methods maybe still better, or they didn't show, the neural networks didn't show better performance than traditional methods. So people also feel disappointed on the neural networks. Okay, so there's a paper called this. Okay, you can look at this one, this paper. A sociological study of the official history of the perceptions controversy. So Minsky, I think this is also a big guy. Sometimes he just is one of the five, maybe the several people in that Dartmouth meeting, right? They also mention about this, just these comments. And then we found that it's difficulty now. We say is intractability is recognized as a fundamental problem. That means the things we mentioned before seems more difficult than we expected, like a machine translation, like a computer vision, like a theory, maybe mathematical theory proving, and chess, and games like this one. So that means, now comes the first AI winter. They now recognize now the difficulty level of the problems. So also followed by the first AI winter, because from the boom, the first boom, cut till this one already have maybe around 20 years, more than 20 years, or 15 years. So people already invest a lot, and then AI winter come. That means the funds from federal government or from the private sectors will become less. So the funding is less, will also cause problems. That means the people will just leave, will leave away from this region, this subject, because there's no funding. You cannot continue your research. And also in company, they don't do this, they will do something else which can get something result quickly. They can make profits. So that's the first AI winter. Okay, so that means from here, that means early around the 1970s at that time. Okay, 1970s. Okay, I think at that time is almost after my 5 years I came to the world. Okay, I was born in 1980, right? So this is late 1970s, so it's almost. So okay, I passed the winter. Okay, I came to the real world now, but even during the winter time, we need to understand, okay, during the winter time, just the fans is less, but still have research going on. And then after around decades, the next boom arrived. That's called the expert system. So why we have this expert system? So maybe we think about this is just preferring we want to solve all the questions within a short time. Seems this is not reasonable. Okay, maybe at the time logic becomes very popular. So we have rules. If we can use rules to decipher or just to conclude the knowledge we have. For example, if like a teaching, like a doctor, like these things, if we have some rule, for example, in fact for us we also learn information, process information, and then we communicate information. Right? If we can use rules to represent the knowledge of the professionals, like I mentioned, teachers and doctors, engineers, then we don't need to hire a doctor, hire a PhD doctor, hire a doctor to do the treatment, hire a person to teach. We just use machines, okay? Because the machine may be even better than me, okay? So this is the expert system. For some, maybe it's working. It's can be say partially working. Maybe cannot say completely working. So that means at that time people want to develop an expert system. Okay. Also, this is also due to the boom of the database. At that time, database is also become more and more popular. We can save a large amount of rules into the disk and then maintain the rules via the database. Okay. So this is the idea. Okay, 1980s, and then later 1980s, expert system burst. Okay, this is seems maybe only a short time, right? Because people found a lot of things cannot be concluded by rules. Okay, if like that, for example, I'm teaching every day, I'm the same. I do the same, is like reading something, reading machine, is that in the same? Because it's rules, okay? So if I read this one is the second AI winter, so just repeat it like this way. So there's no creativity, there's no conscious, okay? You don't because the machine don't know itself. They don't know, and we are people, human being. We have conscious. We know ourselves. We can do creative work, and also we have how to say, we have senses. We care about each other. Machine don't care about each other. Okay? Machine don't have that human kind feelings. Okay? We don't have feeling. Okay, the machine don't have feeling. We have feelings. Okay, so we know. Okay, if you don't feeling good, okay, you have some problem, special problem, we can handle. We can use human beings. Yeah, the how to say, the common language, that common language, common sense to deal with these special things, exceptional things. Okay. For example, if tomorrow we have hurricane, the machine maybe still want to teach. Maybe you want to run, right? Okay. So like this, okay. And then, okay, but you can find it in 1980s that almost very close to the another boom, right? You know that one is internet, right? The 2000. Another after 10 years, the burst of the internet also come. So this one you can find. You need the AI, the IT industry. We just follow like this way. We don't just like a wave, right? We don't follow a straight line, right? That's not possible. Okay, so most industry goes with the same pattern. they will go a wave rather than a straight line, right? So that's reasonable. So not only AI, right? Not only AI, but it's still going up and make breakthroughs during this time. Just similar like our year. Each year we have winter, right? Winter is there, but after winter we become stronger, right? We become stronger. We kill some virus, we kill some bacteria and so on. Okay, and then maybe some plants must go through the winter and then grow. Okay, that's not a big issue. Right? Second winter comes. Okay, because people was disappointed again on the expert system. And then after that, early 1990s till the mid 90. Okay, this is from the mid 1980s till the late 1980s. So along this time, the new network still going on. So even for example, expert system was has a boom. Okay, but the new networks still have people have interest in it, and then people develop the back propagation. Even till now, okay, so then people develop different neural networks. Later we talk about Hopfield networks, and even the deep neural networks in that time already have the idea. Just because people don't have resources to train, don't have good algorithms to train, don't have large amount of data to train it. So yeah, the idea is already there. And the back propagation, this idea, even till now, we still use back propagation for the deep neural networks training. So we study with gradient, kind of gradient, stochastic gradient descent. So stochastic gradient descent, SGD algorithm, but it's still based on the idea, which is back propagation. So what is the back propagation? I will give you a rough idea here. So the network, we have layers. Okay, back propagation means propagate from, this is forward, okay? This is backward. So back propagate the arrow from the last layer to the first layer. This means back propagation. So this is because we know, for example, we want to, during the training, what we want to have, for example, is y. But what we have is y hat. It means it's estimation. So you know the arrow between these two, right? So if you have multiple samples, so you sum all of them together. So this is your arrow, right? This is the arrow. So you can back propagate this arrow from the last layer to the front layer to adjust weight. Why you prepare the arrow? Because you need to know how to adjust the weights in between the neurons. Okay, so that means you update the weights. Because for learning neural networks, the most important thing is you get weights, right? Because the input can be anything, they can change, but the weights will be fixed after training. So this is the idea. After you fix the weights, of course you already decide what's the neural, what's the connection. Okay, and then after that, the most unknown thing is just weights. How the two neurons will be connected to each other. This represents the model. That means two neurons. These neurons, whether there's strong connection or the weak connection. So this is what we want to learn. You need to learn a value. This is 0, between 0 to 1. It's a weight, right? And this weight will decide. So what's the output, right? The weights, those the input, and then based on activation function, what's the output? And then continue. You get from the left to right. You will get the y hat. Okay. When we talk about neural networks, we give more details. Okay. And after that, we have the late 80s, late 1980s. We have a probabilistic reasoning. So at that time, people want to deal with uncertainty problem with uncertainty. For example, whether I want to go to restaurant, I mentioned before, it will be based on a lot of vectors. Whether today is raining, whether that restaurant is fully occupied, how many people are waiting, whether price is expensive or not, whether has a parking place, lots, available lots, a lot of things. All of these things, vectors, will contribute to my decision. So this is not a certain decision. For example, one, if today is raining, I will go. If it is not raining, I will not go. No, if it is raining, I have some chance to go. So it's maybe 50% of chance to go. If it's not raining, today is sunny, maybe I have 90% to go to the restaurant, to eat outside. So that means it's not a 100% rule. Even something happened, it only have some chance to have the result, to have the next event. So that's the probabilistic reasoning. They use the probability. So we want to develop a model to estimate the outcome. We want to achieve maximum expected outcome. This is the idea. For example, if you are running a plant, and then there's a lot of vectors will affect the profit. So you will adopt some strategy, make the expected means weighted all the vectors together based on the probability. And then of course weighted not only just combine together, you need to follow some model. But just considering weighing all the vectors together based on their probabilities, and then you still can get a maximum outcome. That means after 1 year, if I adopt this strategy, I will get the maximum outcome profit at the highest chance, just like that. This is, in fact, in the past year I covered this one. The topic is about the Bayes net. So in fact, it's not so difficult for that one, but just because many students didn't learn probability, so probability and statistics. So that will be challenging for them to understand, because I still need to cover the basic idea about probability and statistics first. So that's why I think I will teach you that which is immediately available for you to learn. So that means we'll cover more learning part. So based learning, if you have learning, you understand what is learning. So if you have learned, finally you will learn some, maybe I believe, some probability and statistics course. So self-learning for that topic is not challenging for you anymore. And the next one will become the great period. So starting from the 1990s, people develop a lot of machine learning algorithms. I think even when I was undergrad students, we still using neural networks, and then we have a lot of other algorithms. At that time, people develop another algorithm called the support vector machine. Maybe you have learned that before. I believe that one is similar like the neural networks, but of course they use a traditional statistics based on math approach. And then people also develop some other algorithms. For example, like AddBoost, we combine several classifiers together. Each one is not strong enough, but we can add them together. So we use like a forest of algorithm classifiers. And we also use some expected method, I think EM method, and something else. I think we use clustering, we use fuzzy method, fuzzy logic to develop some clustering algorithm as well. and then we have KNN clustering, so K nearest labels. So people develop a lot of machine learning algorithms based on statistics. Okay. And then the good thing is that later, starting from 2001 till the present, big data becomes a more and more popular thing. Okay? So we can collect a large amount of data. We also can save them. We also can process them in real time. And the big means variations, speed, okay, variety, like these things. That means they are different types: text, image, video, and audio, and so on. And also the speed in producing the data is very quick, means the velocity. And also variations. Okay, we mentioned variety, variations, and velocity, okay, 3V, and also maybe we have 5 V's. The features of big data. And database related techniques are also available. So big data related to data science, and then because we have a large amount of data, and then it's easier for us to consume those data, and then we can feed this large amount of data into our more efficient algorithms. Okay, especially deep neural networks. Okay, deep learning become a hot topic since 2011. I think at that time it's before that one is lec1 in 2012. We mentioned the ImageNet achieved the best performance, just beat all the previous handcrafted features in image classification. So ImageNet is a large data set, and then based on the WordNet, which is a dictionary, we arrange the words in a hierarchical way, just like a tree, and then we put images on the nodes of the hierarchical tree. There's a lot of images there. And then in the past, maybe people can only get 57 or 60 recognition rate. That means classification accuracy. But using this deep learning method, lec1, even the lec1 is not so powerful. lec1 initially was proposed to do the digit, use the digit meanest the data set, just only the handwritten digits, 1 from 0 to 9. And then later they use it for the image recognition. The achieved may be much better. I cannot remember, maybe 80% or 90%, which is much better than the previous handcrafted features. The good thing is that they don't need to do any handcrafted feature design. They just fit the image into the network directly, and then learn by itself. And after that, we can do the testing. That's great, right? Of course, they will involve the convolution neural networks. They need to do convolution to extract the features. So later we talk about the convolution, just like for example, like our human vision. When we look at an object, we are doing like this way. We don't perceive the whole object right away from one layer. We do it in layer by layer. We first get some edges cut like this. We call it curves, and then based on curve combined together, for example a desktop combined together, we get there's some figures, motifs, we call them motifs, and then motifs combined together we get some components of the object, and then we combine components together, we get an object. So that's how we recognize the object. Okay? You first get edges, combine edges, get some motifs. Motifs combined together get some components, like our keyboards. Okay? You get A, B, C, D, E, F, G. Okay, each keyboard, and then combine them together. Okay, this is for the letter. This is for some commands. These are for some function keyboards. Okay, like this. And then you get the whole object information. Okay, this is about the panel. Okay, we use our hand just like a mouse. So this is the idea, just like simulate the human vision. We use convolution. So maybe you can find we may have a question in our book. Why people, just for example, in fact we use Gaussian filter, So human vision is like using Gaussian filter. Gaussian filter is like convolution. It's a type of convolution. So human vision using Gaussian filter to filter just like you try features. So, but why we have this working mechanism? People don't know well. So our human vision don't code it for this Gaussian filters. So that means that mathematics. What's the relationship between that mathematics and our human brain? So in fact, I think the answer may be just like with the evolution of human beings, and this human vision grows like that way, and then we use Gaussian filter. Gaussian is a function, use still like a probability distribution, like a uniform distribution, like that way. Filter, that means something will depressed, something will be kept. So using that Gaussian function to explain this working mechanism is easier. So that means you don't really do that mathematical calculation. Of course, you will do it quickly. So this is like we use mathematical tools to do some abstraction, make it work, and then we can simulate that working mechanism in computer, make a computer see. That means we have the same mechanism, simulated mechanism. And after that, because this initially is just like some academic improvement, and people found this is really powerful, and then a lot of companies invest. So they hire people. At that time, I think there's a lot of news. For example, in 2016-17, and then I heard some news. A fresh PhD from some California university from California can get a 500K salary per year. 500K. Yeah, really 500K. Yeah, in that. Of course, the reason is that in 2014, I think it's just really from 2014, deep learning became very hot, and then 2016, the DeepMind AlphaGo beat the world champion from the Korea, and then people want to hire more AI experts, but just because of the 2 winters, we don't prepare well for this boom. So even till now, we still have a lot of shortage in this field. That's why I mentioned to many of you, if you really want to see the future, want to catch a job which represents the future, is a very great idea for here. So data science, big data, and AI, I believe these are very good field for you to consider, invest your time. So even till now, I think only a few universities has AI major. Usually they come from different subjects: computer science, robotics control, and even math, and robotics, and so on. Or natural language processing, may come from some different linguistics, something. So that means coming from different subjects, not come just focus. I focus on AI, or some computer science major has an option. Some computer science major or not have option on this one. But the AI major, maybe even till now we don't have fresh graduates. I think starting from last year, 2019, a lot of universities has set it up this major, for the AI major. Even AI college So I believe this is a competition between a lot of countries. That's why you can find there's a lot of confrontations between China and the USA, and also maybe India and maybe Europe. They compete each other in this field. This is all the governments and companies, they see this trend. This is maybe not only temporary, right? So this is like a very natural result. So if in the past we have a computer, and then connect together we have network. So 2000 we have network burst. Okay, after that we have e-business. We can become very popular. And after that we have big data. We can have e-business. And after that we have AI. Now we are entering the deeper water, okay, deep water of the IT. So it is more challenging, but it is more rewarding as well. And everybody want to become leaders of this field. I think in the current way, so most basic framework still comes from USA and Europe. For example, like we mentioned, deep learning frameworks. The most popular ones like TensorFlow, PyTorch, Keras, like these three. They come from the companies Google, Facebook, and Microsoft don't have, I think. And of course, Baidu and something, they also have their own kind of Paddle, and maybe some other Twitter or something. Each one, they want to propose their own framework. Of course, they can also use the existing one. They also build on the basic ones, have their own design, customized thing. Each one want to get a rewarding investment. Okay, just look at the details by yourself about this history. I think it's very interesting about the AI here now. So that means the history will tell you a lot of interesting stories. Of course, the previous researchers build on a lot of basic things, basic tools, basic algorithms for us. Now we are in the best era in this AI road. Okay? So hope each of you can catch this opportunity, and then do something beneficial for the whole world. Because if we learn something, we develop some techniques, tools, products which can do good things, improve our life, that will be very interesting. That's very great. That's also the target for our teaching. We want to grow knowledge. We want to do the good things to the community, to the whole society, to the whole world. Okay. Just read these things, by yourself. The book is also a great resource, and also you can explore others. And then we just finish this history part first for this one. So next one will be something just about the maybe next topic, the AI SAMs. Okay, and some topic about this one. So here we talk about machine intelligence. Machine intelligence is a better word to represent the AI. Kind of mentioned artificial intelligence. This one involves a lot of things like core technologies. Involve these things. First one is artificial intelligence, deep learning, machine learning. Of course, I think maybe this is included into this one as well. Machine learning, NLP, natural language processing platforms, and the predicates APIs. This is related to the statistical learning. We use some statistical learning to do the prediction, called predictive statistical learning, and the image recognition. You can recognize something, and speech recognition. So you can find here all of the things are just like if you talk about a deep Turing machine. Seems like they are needed for agent Agent means AI program, okay? AI system, not a program. AI system to work. You need to understand, okay? Understand humans' natural language. This one. You need to understand the speech. You need to perceive the word, image recognition. You need to do computer vision and make a decision and so on, okay? And other basic things, robotics or something, or logic, probabilistic. So all of the things are needed or necessary for people to develop an AI system. That's why they are the core technologies. That means they will be the basic things that are needed to develop an AI system. And then we have something built on top of these things. We have a rethinking enterprise sales. So that means we think. That means rethink. That means AI will reform these fields. For example, enterprise sales, security, and authentication, and fraud detection. Right? Like we use credit cards, they can detect frauds. Okay, HR and recruiting, marketing, and personal assistant. Okay, important like a Siri. Okay, and also have Google's. Google's have that assistant, personal assistant, digital personal assistant, intelligence tools. Okay, and then we also need to reform industries like this agriculture, education, like Moku online courses, finance, legal, manufacturing, medical, retail, diagnostics, automotive, consumer, media, oil, gas, and also rethinking humans and HCI, like this one. Okay? So AR, yeah, I believe AR or MR, mixed reality, will become another important direction for the future as well. And then gestural computing, for example, use our hand, use our body gestures to control. So it's about HCI, means human computer, means human want to interact with the computer system based on a more natural way. So robotics, okay, emotional recognition, okay, also very important thing, huh? Emotional recognition, and also some supporting technology like hardware, data representation, data what's this one? Data preparation, okay, maybe something else. So related to some lower end, lower end. Okay, NVIDIA, Qualcomm, like these things, they will provide us computing resources, GPU, and the chips, and the data collections, and so on. So big data related things will also be important supporting technology for here. Okay, this is show the big landscape. You can find it has a lot of application domains and it involves a lot of techniques. So that's why I think it will be important, maybe the most important trend. I believe now we are enter in even the second stage of AI area. I think the initial stage is almost done. So that means most things are already very great, very successful. Now we want to utilize the AI techniques in applications. So that means applications are more important now. We enter into that area, not only the theoretical development. Theoretical development already have enough breakthrough to bring a lot of breakthroughs in applications. So once we have those applications ready, they will bring more questions for research. So this is just like a feedback system. Okay. So for here, we mentioned, for example, here we have NVIDIA. We mentioned NVIDIA even developed a deep learning supercomputer. In fact, when I was in the conference in 2016, I mentioned before, in Las Vegas for that CVPR, computer vision and pattern recognition, the top conference in computer vision. So I also saw this machine. I also chatted with the host, and then I'm asked. They said they can give me a discount for academic usage. It's about 15%, yes. But even for that discount, it's still too expensive for me. This 129K. Of course, maybe now it's much cheaper. And my previous postdoc supervisor, I think I've purchased one. They have enough fund to purchase this one, deep learning supercomputer. Okay, let's look at the next one. What accounts for recent successes in AI? I believe here I already answered this question in the previous. So algorithm, computational power, data. So that's the most important thing. Faster computers. For example, here we talk about in 1958, this IBM machine. Okay, this machine maybe is still a supercomputer. Can do 50,000 calculations per second. At that time, they were already very powerful. But Deep Blue, is 2007, correct? Deep Blue, and then could do 50 billion calculations per second. So it's 1 million times faster. Now even more, maybe another million times faster than this one. Okay. So this one shows the resources. Why we want to have faster computers? Because now we have very complicated neural networks. They will do a lot of rounds. We call it epochs training. Epoch means you go through all the data by one time. For example, you have 100 examples. All the 100 examples had gone through the network, finished. That is called one epoch, and then one round. So you need to go finish several hundred epochs, and then the image is not only 100, maybe several million images. You need to go through that network, and the network is also very complicated. The network maybe has several million parameters to train, because you have many layers and many connections. Each connection needs to be trained, the weights. Okay? So that's the reason. Okay. And then we have more solid foundation. We use math. So mainly they're based on the statistics approach, use machine learning. Even our deep learning, our neural networks also based on the statistics learning. Okay, statistics learning. And then big data. So we have a lot of data. We can improve the performance. Small amount of data cannot let the deep learning network demonstrate its advantages. Even maybe compare with some traditional methods, their performance may be similar. That's why we must have a large amount of data. Even the data has some errors, but they can cover a lot of varieties. So like I mentioned, if you see something, next time you meet it, you will know it. So big data means they cover a lot of cases. They cover a lot of different situations, even exceptional cases. So that means make it stronger, more robust. Okay, that's the reason for another reason I mentioned, maybe just like a joke, not a real joke. There's one paper. They want to test different models, different neural network models, whether one is better than the other one. But based on that experiment, they found if the data is big enough, all the networks, all the models, they perform equally best. Okay, equally better, equally, or they can get the best result. Of course, that's within the constrained experiments only for that data. So usually data will contribute to the model. I think we have this conclusion due to the previous experience. Okay, large amount of data. So just be careful when you want to use neural networks, especially deep neural networks for your application developments. Make sure you collect a large amount of data for the problem. Otherwise, maybe you feel disappointed. That's not because your network is not working. It's because you don't have enough inputs to demonstrate its advantage. Okay. So next one, we have crowdsourcing. So that means a lot of people invest, a lot of people contribute, and then we have a breakthrough on this one as well. So next one, we talk about historic SAMs. So we found that it always has this pattern, boom and burst, okay, going up, going down. Okay, periods unjustified optimism, followed by periods of disillusionment and reduced funding. And then we also have this civil bulletism. Civil bulletism, that means whether we can find a good rule to do this. Okay, the tendency to believe in a silver bullet for AI, coupled with the belief that previous beliefs about silver bullets were hopelessly live. So this is just like sometime. For example, in the past, when we define AI, it can do these things. After some decades, those things become real. Is already implemented. So you will raise a bar, raise a bar. So the new silver bullet will be there. So that means you need to do thinking, working like this. So this also, I think, read the book also mentioned about this one. This maybe seems like the reason currently. For example, I said I am an AI researcher. Means I'm not doing research for everything with AI. I only focus on some branches of AI. For example, computer vision related, or something related to the machine learning related, machine learning and computer vision. And then this is called a partial goal. So it's better not only focus on one branch when you set the goal for your research. For example, if I'm doing computer vision, okay, recognize 100%, that's the goal. So we need to think about the basic idea for AI is like we want to make a computer to think, to see, and to create. So this is the general rule. So when we make a decision for our research goal, we need to set the goal in the context of the big picture, not only just doing narrow goals design. Okay, this is what we want to mention about here. And this is AI effect, imagine problems. As soon as the machine gets good at performing some tasks, the task is no longer considered to require much intelligence. For example, in the past, we talked about intelligent mobile devices. But for those intelligence now, we don't think intelligence, okay, like the lot of apps, and using touch screen. And then we can do a lot of easy things we call during driving and so on. We think this is already very social, It's live. So we have raised the bar a lot. We want to the mobile device has more intelligence. Even we can use the mobile device to do all the things. Okay. This is called the AI effect. And the next one, AI as a threat. So we will look at details in detail in the rest. Okay, we talk about AI benefits and the threats. So here we talk about some examples, and of course we are mentioning them as well in that section. So this is about AI weapons. Maybe this is the biggest concern we need to talk about AI threats. So here we can just mention about this is a threat to humanity owned Hawking. Okay, you know this scientist. Okay? So it's Stephen Hawking, the physicist Stephen Hawking, and Elon Musk is a famous person now. Okay? From the Tesla. Okay? Elon Musk, and then we have the Apple co-founder Stephen Wozniak. Okay, they argue that AI has reached a point where deployment of robotic weapons is feasible within years. So if we develop AI weapons and use AI weapons to remove human targets, but if we just like here can select and engage a target without human intervention, if we don't have a human intervention, so these AI weapons maybe can be controlled by a small group of people. So this small group of people maybe do harm to a large amount of other people. So that means if AI weapon has been controlled by a small amount of people, for example, for the better people, some better people, they want to do better things to the whole humankind, then AI weapons can replicate a lot. They target, for example, remove all the people except their own, remove all the male, all the female, all the American people, all the Chinese people, for like this one. This is really bring a lot of concern, because if people doing these things this way will bring disaster to our home humankind, even worse than nuclear weapons. Nuclear weapons maybe cannot like this bad effect, okay, because they can do large scale in this one. Okay, we mention about this one a little bit in later section about when we talk about AI threats. Okay, you can read this news as well. So that means 100 people signed on this letter. Okay, and next one is about the whether this is a long topic, a long history question, correct? So whether robot will replace human jobs, so will cause a lot of unemployment. So we have a long debate. Till now, we don't have answer. Even experts don't have answer for this one. Okay? Experts can't decide. Will robots take our jobs? We have two effects. Because they can bring good things, they can also bring bad things. Okay? They can make some jobs obsolete. For example, like automobile, okay? assembling the automobile. So you can find that rust, okay? Rust belt, for example, Michigan, Pennsylvania, and Ohio, that region. In the past, we have a lot of workers in the automotive, automobile industry, but now there's less. They moved due to, for example, they shift to other countries, or they most important is not only shift to other lowest labor, for example, they have lowest labor prices countries. The other reason is that even they shift the plants to other countries, they also have a lot of robots do the assembly in those plants. So the job is already gone. So maybe permanently, not only temporarily, correct? But also you can think about we can free the people, correct, who need to do that repetitive work. Though of course it may be rewarding in that pastime, but this is good for people to raise their skills, and then we can have cheaper cars. We can have better cars. We can improve our life. So it has costs. It will bring both benefits and impacts on people. So benefits to people, impacts on the employment. Okay. So it's a lot. Cannot say it's only good, or sometimes we cannot have only two answers, good or bad. Okay. So next one is AI a threat? Next one is more down to the earth. Is concrete AI safety problems. So we have this. I think we have these problems we mentioned here. So concrete AI safety problems like safe exploration, robustness to distribution shift, avoiding negative side effects, avoiding rewarding hacking and while heading schedule. Okay, just take a look about this one. Okay, related to this one. Okay, and the next one is moral vex paradox. So here is about just read this one. What's this paradox? It's comparatively easy to make computers exhibit adult level performance on intelligence tests or playing checkers, and difficult. That means easier to do something complicated, but difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. So this means some basic behavior humankind have, we still have a long time to do. For example, like walking, running, and speaking, understanding natural language, like these things. But doing some complicated things, so that's called a narrow AI, is easy to be achieved. But general AI seems harder to be achieved. So in fact, in the course, in the book, we also talk about, in fact, we can think about 3 parts. So below the AI, below the, for example, simulated AI, just like okay, that's called narrow AI. And then we have some general AI, that means it can do everything like a human, so called artificial general intelligence. And then we also have some machines just above, because they can, now we have that concern. Okay, they can do better than people. So we can say this is called with another name, just like a surpassing maybe artificial surpassing intelligence. I think you can read the book. There's a discussion in that in AI benefits and risks. They talk about these things. Okay. So general AI, in fact, now we have an organization called Open AI, which is dedicated for this one. Just develop some general AI systems and algorithms. Okay, they all have some breakthroughs there. I think they ever develop just natural language model. Okay, very powerful. And then there's a undergraduate student from Canada, and then just the senior student, based on that model, develop a AI tool. Just want to, for example, when you are coding, for example, for F, when you write 4, they will just promote you. Okay, complete the word FOR, so you don't need to write the whole word. So it's just an AI code completion tool. I think that student already make a lot of money from that tool. Each subscription, maybe only $40, but for personal usage it's free. But for company, the large scale usage, you need to pay some subscription fee, and then there's a lot of sales for that one. It's very powerful. Okay, you can look at that news. Maybe I forgot the name. but yeah, it's there. And why might this be? I think this is because human intelligence, sometimes the working mechanism till now we still don't understand. So simulate that mechanism is not easy. And the other one is that lateral AI is easy to be achieved, and general AI is hard to be achieved. Yeah. So that's why I think most companies just focus on one or several, just lateral AI. So that OpenAI just focus on the general AGI, artificial general intelligence. So to provide some foundation for the future. Okay. So focus on this type of problems. So early AI researchers concentrated on the tasks that they themselves found the most challenging. Abilities of animals under 2 years old were overlooked. This is one reason. So we are least conscious of what our brain does best. Okay, we don't know the mechanism. And the sensory motor skills took millions of years to evolve, while the abstract thinking is relative recent development. So this goes with a long history, so it's even harder for us to understand. Even it's basic, right? Sensor motor, that means like a seeing, hearing, and smelling, and like these things, right? But the logic thinking, like the abstract thinking, we have some advanced knowledge to represent this one, like logic, right? Logic and reasoning, probability, like those things. Model, we have mathematical tools to explain this one. But like this one, we still have a far way to understand those things as well. Like human brain, right? And related to vision, computer vision, and the brain. Okay, brain working and thinking, like these things. So let's look at, for example, we talk about the previous one. It seems like we want to simulate our brain. This one is like we put these two things together, compare the human brain and the computer brain, right? Like a machine intelligence. So thinking fast and slow. So that means fast, of course, is computer, okay? Slow is our brain. So fast, that means compare their characteristics, features. This is fast, is automatic, and subconscious. That means don't know itself. Emotional. For example, like detect hostility on a face or in a voice. Orient to the source of a sudden sound. Answer 2 plus 2. Read words on large billboards. Drive on an empty road. Seems like these things is easy to be achieved by computer. But slow one is a human brain. Slow, effortful, logic, calculating, conscious. Focus on the voice of a particular person in a crowd and a noisy room. So that means even it's crowded and noisy, we still can focus on, we constraint. So constraint, we know what we want to do. We have effort, okay? So can we say a computer has effort? Okay, make it run all the time. That means, but we can adjust our strategy, okay? We don't need to follow algorithm. Okay, we can focus. Search memory to identify a melody, like these things. So we may use some other things, not only just some logic things. We can use a lot of thing mechanism we don't understand now. Count the occurrences of the letter on a page. Compare, this is slow cut for us. Compare two washing machines for overall value. Okay, we can use overall justification. Okay, logic calculating conscious. So we don't need to, so maybe for computer don't know how to do that. And fill out a text form. We can use our existing knowledge, existing memory, and a lot of things, and learn the skills to do that. Check the validity of cannot move this one. Okay. Complex logic argument. Check the validity of complex logic argument. So that means a human can do something, but challenging for computer. Computer can do something easily, but challenging for human. We have this. So it's better we complement each other, rather than one replace. We don't want to teach computer to be more smart, to be smarter than people, and replace us from the world. We also want to use use machines to help us to lead a better life, to improve our world. So we don't want to, just because it has some negative impact, potential negative impact, then we don't use it, or we don't have any rules, we don't have any regulations, just let it free do anything for us. No, we need to use some restricted and how to say with regulations, governed rules. We have some organization to do this. Okay, so let's maybe just stop for this part, and then we'll continue for the next one. It's about AI benefits and the risk. This is also an interesting and important topic. Okay.